Thank you for attending this webinar sponsored by NEC Corporation. To learn more about the Programmable Flow networking suite featured in these use cases, please contact your NEC account rep today or go to NEC Corporation of America's website at www.necam.com/SDN.
To find additional SDN, OpenFlow, and network function virtualization resources, visit ipspace.net/SDN. Isn't the difference between proactive and reactive mainly in the triggers? Eventually, even in the reactive, punting is followed by proactive flow setup in other switches. Hopefully. I'm positive there are controllers out there that do punting switch by switch by switch, but let's not discuss that stupidity. You are right. In a reactive setup, you will install entries in all switches on the path. The question is, how many triggers do you get in a time unit? In proactive setup, you try to minimize the number of triggers, whereas in reactive setup, you might get plenty of triggers and that might overflow the switch. So if you remember the fast switching in Cisco IOS that was used in core internet routers in those days, when people started port scanning the internet, the number of different cache entries that had to be brought into the fast switching cache caused brownouts or even blackouts because the fast switching cache was overloaded. The same thing here. The more proactive you can be, the more you go toward what, for example, Cisco implemented in those days with self switching, the safer and the more resilient your network will be. So try to be as proactive as possible. Then there's a question about in-band versus out-of-band switch to controller communication, which is most widely used today. In most cases that I've seen, people would rely on an out-of-band control plane. In-band control plane is risky because if you install wrong OpenFlow entries in intervening switches, you might cut yourself off from an edge switch, for example. And also, remember that if someone gets connectivity to your control plane, they can do all sorts of weird things. So like in the traditional, let's say SDH networks, most people would use an out-of-band control plane for performance, security, safety, resilience, you name it, a number of reasons. Next question, when we were discussing path forwarding, does it mean that full mesh of tunnels should be built in advance, and is it scalable in case of big networks? Ideally, you would have a full mesh of paths. Do remember that NEC can have 200 switches controlled by one controller, which is the domain of path forwarding, because as you go out of that, you are back to traditional layer 2 or layer 3 forwarding. And among 200 switches, there aren't that many paths anyway. Are there use cases where WAN and LAN flows can be influenced end-to-end using SDN/NFV? There are people using NFV for all sorts of things. I sort of touched on that in the service insertion case. I was talking about load balancers and firewalls, but you might insert whatever you wish there. Also, if we look at a more generic scenario, there is, for example, the Deutsche Telekom network. They have a pilot in Croatia where they use NFV for termination of IPv4 over IPv6 tunnels. And you can call that SDN. So effectively what they're using is they're using an API to the appliances to configure new users. So yeah, that's an interesting NFV/SDN use case. But I didn't mention it here because it has nothing to do with OpenFlow. Is there some sort of rule of thumb for the number of controllers that you should use in your data center? Well, keep in mind that one controller cluster could be potentially one failure domain if you hit a particularly nasty software bug. So you would always want to have 2 controllers at least in a cluster for redundancy and high availability. And then whenever I would design a large-scale data center, I would split the data center in availability zones. So if whatever happens in one availability zone, another availability zone is still available. So if I would go and implement my data center with OpenFlow fabrics, then I would have a cluster of controllers for each availability zone, and then link availability zones with something traditional like layer 3 forwarding, for example. Samrat, would you add to that?
Yeah, I think that's very good, correct. Also, we can add more controller redundancy in future so that even a single availability zone provides further redundancy for predictions.
Could you address which of the limitations you mentioned in OpenFlow 1.0, 1, or 1.1 have been resolved in the 1.3 version? The best answer to that question, just go and read the OpenFlow specification release notes. They are really good, and you will see immediately what has been added to individual versions of OpenFlow. For me, the most critical parts were table support and IPv6 support. And I think now there's official support for multiple controllers. Not sure about that. But as I said, OpenFlow release notes at the end of every OpenFlow standard document are a great source of information of what has been added. There was a question about QnQ support in OpenFlow. Generic answer is yes, QnQ is part of the OpenFlow standard. So you can match on the tag, you can pop the tag, you can add the tag, but I don't think QnQ, at least on the edge ports, is available with ProgrammableFlow.
Yes, it's correct.
So if we need to do packet replication in the network, for example, for multicast or flooding or something like that, does the replication also happen in the ingress node, or do we do replication in the core of the OpenFlow fabric with ProgrammableFlow?
So you can do that type of replication at any switch. For example, ProgrammableFlow can create broadcast trees or multicast trees over the whole network. So just like you see end-to-end path, you can also have a tree defined on an end-to-end basis for replicating the packets over the switches. But so far we use that for certain specific purposes. In other words, we do not provide a multicast type of support without the specific needs.
Can you use OpenFlow for stateless IPv4 to IPv6 NAT? No, you can't. I don't think there's any action in OpenFlow standards today that would allow you to rewrite the IP header from IPv4 to IPv6. You can rewrite all sorts of things, but you cannot rewrite a destination IPv4 address to a destination IPv6 address. So no, you can't do that with OpenFlow. If you have servers connected with 2 interfaces to the fabric, and the server is a Linux server doing transmit load balancing, which, if I understand it correctly, would mean that it transmits from 2 different MAC addresses. So I guess that shouldn't be a problem for ProgrammableFlow Fabric because it sees 2 different MAC addresses. And if the server wants to use the same MAC address on both interfaces, then you would probably have to connect them into a port channel and handle that properly. Is that correct?
Yes.
We covered this one in ProgrammableFlow webinar, but Samrat, if you want to go into this one again, do you have any high availability use cases in regard to multi-controllers, such as how will you sync the state between the active standby controllers?
So we do have between the active and the standby controllers memory synchronization of the states, and there are also other persistent states level synchronization happening. However, the memory synchronization allows rapid standby to active creation so that you do not lose any time when the standby comes back. So that's the way we take care of the active standby scenarios.
Outside of OpenStack, is OpenFlow available with the vSphere distributed switch? Because customers are complaining that their only option is Nicira/NSX.
At this point, we do not have any plans.
Next one, by controlling the Open vSwitch, will VM migration become faster? I mean, forwarding the VM image using path-based forwarding. I don't think so. So first you have to remember that VM migration, and if you talk about OVS, it's between Linux-based hypervisors. It doesn't happen through OVS. It happens through the uplinks, but using directly the TCP stack in the Linux that is hosting the VMs. That is sort of out of range of what the OVS switch sees. You can definitely use an OpenFlow fabric to send traffic, let's say vMotion traffic, however that's called, over separate paths so that vMotion traffic will not impact the user traffic or vice versa, or that vMotion traffic will get dedicated resources. But this has nothing to do with controlling the OVS in the hypervisor.
I think that's good. That's right. The only difference in case of OpenStack is that you are able to automate the stitching of the VMs to the overall tenant network, but otherwise, in the case of OVS support, it is just acting as a switch. It doesn't add any additional things than any normal network switch would do.
Can you please clarify an issue with a connection between controller and switches? If we, for example, have a ring of OpenFlow switches and they are communicating with controller via one particular path, in case of connection break on that path, how will switch and controller communicate in order to establish a new path if we are using reactive approach? You have to keep in mind that the communication between the controller and the switch on the control plane is pure IP communication. So the two are not involved in any forwarding decisions. They act like IP hosts. So in a typical resilient OpenFlow deployment, you would have the data network, and then you would have the control plane network. Data network controlled via OpenFlow, and on the control plane network, you would use whatever traditional equipment you want to use. So if we're talking about WAN use case, then you would use exactly the same approach that you used with your SDH or Sonnet boxes before. So you would have an out-of-band control plane network, which would be built with traditional routers or whatever you wish to use. And the OpenFlow controller and the OpenFlow switch would use that IP network to communicate with each other. And if that network breaks down, then it's the responsibility of that network to reestablish connectivity, because the controller and the switch are on the control plane just IP hosts. They cannot do anything to get in touch if the underlying connectivity is not there. Please define what you mean by an availability zone. An availability zone is a single failure domain. So if something fails really badly, that failure should be limited to one availability zone. This is like what Amazon has. They have one data center, but within data center, they have isolated or semi-isolated islands, so that if something really bad happens in one island, you know that the other island will still be operational. And then the best practices for application deployment say that you should deploy servers and database instances for your application in different availability zones, so that if they lose one availability zone, you still have your application up and running.
To learn more about the award-winning NEC ProgrammableFlow networking suite or the complete SDN ecosystem NEC is building with partners, and how you can customize these use cases for your own networking needs, call your NEC account rep today or go to NEC Corporation of America's website at www.necam.com/SDN. Thank you for your time and interest in NEC.
Additional SDN, OpenFlow, and network function virtualization webinars, recordings, and workshops, as well as other resources like books and case studies, are waiting for you at ipspace.net/SDN.